Hi, I'm Dennis Frechette, and welcome back. Today is part two of my Openwork project, and if you don't know what I'm talking about, you can go back and look at part one to get caught up, and the link for that will be in the description. If you watch this video and you're kind of interested, but you know you don't want to watch the whole thing, I will be producing one video at the end that'll kind of sum up the whole process, so you can just wait for that one if you like. And as always, check the description for other related videos. Hope this helps you out. I'm going to start today by showing you an updated version of a work holder that I built several years ago. And I built it specifically to do this kind of work, but it turns out that it didn't really perform all that well. I still use this all the time. It's great for clamping pieces horizontally in a vise if you need to weld or grind or do any other kind of operation like that. I pretty much have this mounted in its own vise all the time. It just doesn't work well for what I need to do today. As you can see, the new version is quite a bit heavier. I didn't use a piece of angle iron as a base. I welded together some blocks of 1/2 inch by 3 flat bar. And this is extremely solid. There's absolutely no flex. So every time you hammer the chisel, all of that energy goes directly into cutting whatever it is you're working on. The other big difference that you'll notice with this version is that I've gone ahead and welded a solid stop all along one edge. This edge is designed for exactly what I'm going to be doing today, which is working on a strip of sheet metal. But if I decided that I needed another jig that was a little more specialized, I could build that on a separate plate, lock it up against this shoulder and work with that. So even though this wasn't designed as a multi-tool, it does have some flexibility to allow me to work on a variety of different pieces. I'm ready to get started, and you'll notice that I don't have any drill holes in the plate, and that's because I decided that I wanted to be able to do this process without that initial step of drilling a whole series of holes. The holes do remove a lot of material, and they're great for that, but they are really tedious to lay out and to drill out, especially if you have a complicated pattern. I'm still using the same chisel that I used in the last video, but I have done quite a bit of grinding on it. I found that the base of the chisel was a little bit tapered, so as I went deeper into the metal, it would start to hang up and really provide quite a bit of resistance, as well as a lot of torn edges on the surface that I didn't like. So this has a much thinner profile, so hopefully it'll glide through a lot better. I'm also not working with a pattern. I'm just going to be cutting a free-form shape into the surface. I'm not after a finished product. I just want to try out some ideas. At this point, I'm pretty much through the plate. The metal underneath the chisel is so thin, it doesn't even support any more cutting, and you can see how it's creating a raised surface on the underside of the plate. Here I'm going to try clamping the hole over the edge of the fixture, and I'm just going to use a regular chisel to drive it along the cut line just to see how easy it is to shear this slug out of the plate. And I'm definitely left with a hole that has much cleaner edges than the first attempt that I made. So I definitely think that I'm going to keep experimenting with this approach. One of the things I realized when I was chiseling out the center of the hole was that I do need to build a spot into the plate where I can support both sides of the plate while I'm doing that work. So that's what I'm doing now. I've drilled 2 holes in the plate and they are laying out the length and the width of the slot. The shallow drill hole is the depth, basically that I'm going to, and the through hole is just a way of getting anything that's building up inside of that slot out of the plate without having to totally remove it from the vise in order to empty out whatever is building up in there. I don't know if it's going to work or not, but it was easy enough to drill all the way through, and it's not going to harm anything if I don't need it. I decided to use the same chisel that I've been using, basically just to see if it'll cut to that depth. The initial cuts that I made worked very well. Now I'm going to see if I can take a little bit deeper cut and remove more material at a time. And now you can see that the chisel doesn't want to do that. Here you can see how the chisel now has kind of a hockey stick shape to it, which is very interesting because if the chisel was too soft, it should have curled like a scroll, but there is a straight line leading to a very hard bend in one specific area. Also, the cutting edge is still sharp. It's perfectly fine. So what I think happened is that I've just run out of the temper at the edge of the tool. Again, these are chisels that I've had for years, and I've just been regrinding them and regrinding them and using them. But there comes a time when you've ground past that whole hardened edge, and I think that's what's happening here. I have a little bit of a hardened edge, and just beyond that, the chisel is starting to get soft again. And that's where the bend happened, right in the transition from the hard cutting edge to the softer steel behind it. So my thinking is if the cutting edge is still good, I'm just going to straighten this thing back out and see what happens. I'll concentrate on taking lighter cuts because this bend happened because the edge happened to dig in a little too deep and I was trying to hammer it back out of the cut, and that's when the bend happened. So I think if I just take the cut that it was designed to take, everything should be fine. And if it bends again, I'll just straighten it out again until I get a total failure because regardless, this chisel, when I retemper it, I need to grind it back beyond that bend point anyway. So there really isn't anything lost here. I certainly don't recommend you straightening out and keep using chisels that you plan on using all the time, but this is just an experiment, and these chisels are basically being sacrificed for the experiment because I'm just grinding and reshaping and doing everything that I need to do with these chisels to get through the process. And then once I decide on the final shape of the chisels, then I'll make, proper chisels that'll be well looked after. But for now, I'm really interested in seeing how much this chisel can take now that it's failed once. So I'm just going to keep pushing it until it totally collapses. I have to say that I'm really impressed with how well this chisel held up, because these cuts are easily twice, if not three times, the thickness of the original sheet metal that I was using earlier in the video. So they've gone really far into this plate and everything's fine. I ran into a couple of problems when I was taking a little too heavy of a cut, but I straightened the thing back out and it just kept on going. Also, it's the original grind. I did not sharpen that chisel through this entire process. So the reason I cut this series of grooves into the surface is because it really reduces the amount of work that the other chisels are going to need to do to create this depression. Now I can come in with much heavier chisels and start prying up all the material in between these grooves. These relief cuts act as break lines, and they allow quite large pieces of metal to be pried out of the surface. So if I didn't have these cuts in the surface, I would have to work a lot harder with the other chisels to get to the same depth, because I would need to take a series of much lighter cuts to get the same result. Once the bulk of the material has been removed, I can go back to a simple engraving chisel and clean up the surface. So that's where I'm going to leave it today. I have a few things that I've identified that I need to work out for next time, and we'll see how it goes from there.